Hi guys, this is Miss Colson, and today we're going to look at the differences and similarities between ionic covalent and metallic bonds. In an ionic bond, electrons are transferred, they are shared for covalent, and metallic have that delocalized sea of electrons. Which type of bond? Ionic have metal and a nonmetal, or a polyatomic ion. Covalent have only nonmetals, and metallic are only metals or alloys being something that is several metals mixed together, but it still has only metals. Ionic bonds, for their conductivity, are able to conduce electricity if dissolved in water, because when dissolved in water, those ions separate, or in their molten state, meaning their liquid state. Covalent bonds are not conductors of electricity. They are called non-conductors, and metallic bonds are able to conduct electricity. To name an ionic bond, we do not use prefixes, and we use Roman numerals if a transition metal is present. There are two exceptions. Silver and zinc are transition metals that do not get Roman numerals. Tin and lead are not transition metals, but they do get a Roman numeral. Covalent bonds have prefixes, and metallic bonds we use the name direct from the periodic table. To write an ionic formula, we are going to crisscross and simplify. A covalent, we're going to look at the prefix, and we are going to write however many each atom has based upon the prefix used. We do not simplify covalent bonds, only ionic. Metallic bonds, we write their formula simply by using the symbol of the element direct from the periodic table. Ionic bonds structure is formed that crystal lattice, and the formula represents the unit cell, which is the smallest ratio of cations to anions. Covalent molecules are going to form molecules with our Vesper shape theory. Ionic bonds, for our Lewis dot structure or electron dot, we transfer electrons. The cation has no dots, the anion has 8 dots, and we put the charge or oxidation number for each of the cation and the anion. In a covalent, the Lewis dot or electron dot structure shares electrons. The dots are going to equal the number of valence electrons, and you're going to have 2, 4, 6, or 8 in that final structure depending upon what element is used. Metallic, you simply draw the number of valence electrons. Ionic bonds have the highest melting points, covalent bonds have the lowest melting points, and metallic bonds are in the middle. The same holds true for boiling points. Ionic have the highest boiling point, and covalent have the lowest. Ionic bonds are generally a solid at room temperature. Covalent bonds tend to usually be a liquid or a gas, and metallic bonds tend to be solids at room temperature. The electronegativity difference, when we work out the electronegativity difference, anything greater than 1.7 tends to be ionic. A covalent bond, if it is a polar covalent, it is going to be between 0.5 and 1.7, and a nonpolar is going to be anything below 0.5.